Hi, Year 11. What we're going to have a look at now is the double angle formula that relates to 17E in Cambridge. So we want to have a look at how we would prove these formulas because part of the extension course is proving our formulas. So you want to prove that sine of 2A, there's our double angle, is equal to 2 sine A cos of A. Now we've got to think, if I'm starting at sine 2 of A, think back to our last exercise and I could write sine 2 of A as sine of A plus A and pop that into our compound angle formula. So popping that into our formula, we would get sine A cos A plus cos A sine A. Those are the same, sine A cos A, sine A cos A. So we've basically got 2 sine A cos A, which is our other side of the formula. So that one is proved. Similarly, let's look at the next one. Cos of 2A. Using our compound angle formula, cos of 2A could be written as cos of A plus A. Let's go back and check that formula. That would give us cos A minus sine A sine of A. And I've just read that straight off the HSC formula sheet. So I've got two lots of cos A. So I've got cos squared of A minus two lots of sine A, which would be sine squared of A, which is our right-hand side. So we've proved that one. There's two more rules down there. Now cos 2 of A, we want to show that that equals 2 cos squared of A minus 1. So we've got cos on the left and cos on the right. So that is going to be using the formula above to get that one out. So let's just start with that. Cos of 2 of A is going to be equal to cos squared of A minus sine squared of A, which we've just shown. But what we want to do is show it equals something that doesn't have any signs in there. So we want to do a replacement for our sine squared of A. Now we know that cos squared theta plus sine squared theta is equal to 1. So if we just do an arrangement of that formula, sine squared theta is going to be 1 minus cos squared theta. So sine squared A is going to be 1 minus cos squared. Oops, A, not theta. We don't want to put theta in there. Now it's minus the whole thing. So what I'm going to end up with is cos squared A, taking that minus through, minus 1 plus cos squared A. So I have 2 cos squared A's minus 1, which is what we were requiring up the top. Let's look at the next one. Okay, so that cos of 2A is equal to 1 minus 2 sine squared of A. Similar proof. Cos of 2A, what did we do up above? We said it was cos squared A minus sine squared A. Cos squared A minus sine squared A. What we will notice that this time we only want our answer in terms of sine. So we're going to remove the cos using our cos squared plus sine squared is equal to 1. So cos squared is going to be 1 minus sine squared A. And we're going to take off another sine squared A. So it's 1 minus sine squared A minus another sine squared A is minus 2 sine squared A's. Now if we jump back and have a look at the HSC formula sheet, okay, you do not have those on there. Okay, so you need to be using these compound angles to get a lot of the things that we just worked out. We'll jump back into our sheet. Okay, so you're not going to be given these formulas. You need to work those ones out yourself. So following the same rules as above, to get tan 2 of A, I've written it as tan A plus A, and just pop that straight into the formula that is on our HSC formula sheet. So we'd get tan A plus tan A over 1 minus tan A, which means we've got two lots of tan A on the top line, and our bottom line is 1 minus tan squared A, which is what we were required. Okay, so here's our first example. Cos of theta is 3 over 5. Theta is acute, so theta's in our first quadrant. Find the exact value of cos of 2 theta. 2 theta is a double angle. Okay, so again, in an exam, you're not going to be given the formula for cos of 2 theta. So you need to know that cos of 2 theta is equal to cos of theta plus theta, which is a compound angle, which we do have a formula for. So you're going to go and work that out, which we've just worked out above. Go back above to where our formulas were. Cos of 2 theta is, and we've got our, needing it to be in terms of cos, because we've got cos there, is going to be 2 cos squared theta minus 1. So it's 2 cos squared theta minus 1, which is 2 lots of, we've got cos theta as 3/5. So we're squaring our 3/5 and taking 1 off, which is 2 lots of 9 on 25 minus 1, which is 18 on 25 minus 1. Putting that in your calculator, you'll get minus 7 over 25. Let's look at the next one. Similar way, sine of 2 theta. You don't get that given. You need to know it's a compound angle, and you need to work out sine of theta plus theta and pop it into the compound angle formula. We need that, however, to be involving cos, because we have cos in there only. So what we're going to do is go and look above it. We're not going to look at T formulas. Up above, what we just worked out was that sine of 2a was 2 sine a cos of a. So sine of 2 theta is 2 sine a, 2 sine a cos of a. So let's pop that in. Cos of 2 theta is 2 sine theta cos of theta. Now what we know is that our cos of theta is 3/5. So if I just draw myself a little right angled triangle and pop theta in there, and theta is a cube, we've got 3, we've got 5. What's our side of our triangle there going to be? It's going to be 25 minus 9, which is 16, and that's going to give us a 4, square root of 16, which is a 4. So I can use that triangle to find my requirements over here. So I've got 2 lots of sine theta. So 2 lots of sine theta is opposite on hypotenuse, 2 lots of 4/5. We were given the cos theta, which was 3/5. And now we're going to have a 25 on the bottom. 4 3s are 12 times 2 is 24 on 25. Okay, here's our next example. And it says find the exact value of 2 sine 15 cos 15. And it does say exact. So you're thinking, okay, what can I do there? You're going to need to practice these a lot to recognize what our rules are. And that should look a little bit similar to something we've seen above. 2 sine a cos of a. Scroll up to the start of 17a. We worked out that sine 2 of a was 2 sine a cos of a. Okay, it's not given to you on your formula sheet, but you either can memorize it or we're going backwards. So 2 sine a cos of a comes from sine of 2 lots of a. Okay, so we can work that out here. So if we've got 2 sine 15 cos of 15, that's going to be equal to sine of 2 lots of 15, which is sine of 30, which we have our special triangles for, which equals 1/2. Let's look at the next one. Okay, 2 cos squared of 22.5 degrees minus 1. Okay. So I can't just look at that question and see what's happening. So let's just get rid of that angle and write it as 2 cos squared a minus 1, where a is 22.5. Going back to our formulas before, here's something that looks similar to that. 2 cos squared a minus 1, that was cos of 2 of a, which therefore equals cos of 2 lots of 22.5, which is cos of 45 degrees, which we can do in our special triangles, which is 1 on root 2. Scroll down a little bit further for our last one. We want to simplify 1 plus 2 cos theta over 1 minus 2 cos theta. Now again, I really suggest that you remember the rules for cos 2 theta, and we can pop that straight in there. But if you can't, you're going to have to go back to first principles, in which case you're going to be writing that as cos theta plus theta, and the same as for the bottom, and just doing your algebra to get that out. So you can do that, but it will take a little bit of time. I'm going to use the rules from above that we've already worked out, because we've gone from first principles already. So 1 plus 2 cos theta is equal to, actually, scroll back up and have a look up here. So it's not directly equal to this, but 2 cos theta is equal to 2 cos squared theta minus 1. So 1 plus 2 cos theta, I need to add 1 to both sides, is going to be equal to 2 cos squared theta. So there's a little bit of manipulation there. Is equal to 2 cos squared theta. So on the bottom line, 1 minus 2 theta. Let's go back up and have a look at what that's going to be equal to. So I've just popped a direct substitution on the bottom for the cos 2 theta, which is 2 cos squared theta minus 1, and I've got 1 minus that. I've already simplified the top line. So the bottom line is going to be, what are we going to have? 1 minus 2 cos squared theta plus 1, which is going to be 2 cos squared theta over 2 minus 2 cos squared theta. Okay, we're nearly there. Let's just factorize that out. The top one is 2 cos squared theta. The bottom one I'm going to factor out a 2. So I get 1 minus cos squared theta. We know that sine squared theta plus cos squared theta is equal to 1. So for the bottom line, our 1 minus cos squared theta is going to become sine squared theta. So what we end up with is the 2's cancel out and we end up with cot squared theta.